let's get started on show and tell. If there's anything else, okay.
So this is a robot that we are building for mech warfare for Robo games this year. We didn't finish it for the Robo games last year, so it was competing in stair climbing. But this year we are hoping to actually finish it. And I will show just how it moves. The guns are not connected for public safety, so...
Sure. Is this from Mech Warrior?
Yes. And we have also hooked it up to ROS and the ROS navigation system, so I can actually try if it still works. Okay, maybe later. It takes time to set up. So that's it for now.
Okay, so this is our robot for Robo Magellan, and so right here we have 3 touch sensors in the front and 2 ultrasonic sensors. And we have 6 motors and 2 battery boxes on the bottom, and an NXT Mindstorm NXT brick up here. And this all runs on 6 batteries in here, and then 10 batteries in here. So we have an Android phone, and it's connected with Bluetooth from the Mindstorm brick and the Android. So it's supposed to go forward, backward, and turn. Oh yeah, the programs, the first program is for obstacle avoidance. So what happens is that if any of the touch sensors are pressed, then it will turn away, or if any of the ultrasonic sensors detect it, the object, then it will also turn away. And the second program was the program that would allow the NXT brick to connect with the Android phone.
So it's taking us longer than expected. Can you hear me? Okay? No?
Talk louder.
All right. Yeah, that's right.
Hello? Oh, cool. So it's taking us longer than expected. Turns out that Lego is really not designed for making big, heavy robots. Like this robot weighs a little more than 6 pounds, so we burned quite a few parts. I think it consumes somewhere between 30 and 40 watts, and 6-7 watts when all the 6 motors are stalled. So Lego is really not designed for that. But we found a way to not burn any wires or motors anymore. So, but it's taking us longer than expected, and unfortunately, it seems like we will not be able to participate in the Robo Magellan this year because it took so long to make this robot. But the good news is that we do have pretty good platform, so we can try and now integrate the Android phone into, I guess, obstacle detection and obstacle avoidance and cone detection. So that's what we're planning to do next, is trying to, we already have a way to send commands from Android phone to the NXT brick. So now we just need to use all the sensors inside of that Nexus, Galaxy Nexus phone to direct the robot. And so hopefully next year we'll actually be able to participate in Robo Magellan. I don't know, do you want to show? It's a big robot, kind of hard to show it working on a table, so we have this box. So just one, I guess. So it's actually pretty powerful. It can go in the grass. Yeah, we'll show afterwards how it avoids obstacles, it bumps and goes around. So that's we'll show it later. Thank you.
No questions. Okay, that's a wonderful looking robot. So the next presentation is Daniel Melder. We want that out there.
Testing 1, 2, 3. Testing. Okay, great. This is one of those things where, hey, it was working a minute ago.
It's got a bad motivator.
More than likely, it's just a line. Otherwise, you can scan. If you keep rebooting, it's because his batteries are weak and I should have charged them. Don't you hate when that happens? There we go. Okay, just let me stretch this out a little further. Okay, so this is the telemetry coming off the robot. The R is the right leg and the L is the left leg, and the first 5 numbers are the current servo numbers. And these are the weights on the load cells on the bottom of the feet. This is the total weight. And this number here is how many sensors are actually touching the ground in bit format. So touch it down. Up. That rebooting means that he's got a power surge, which means the battery isn't enough to handle it. So, come on, you can do it. Yeah. So, don't fall yet. So this is the Joe Knee Walker, and named after my girlfriend Joanne, and the fact that it gets drunk all the time. I started this about 4 years ago and haven't worked on it in 2 years, and then dug it out of the closet about a month ago when I got laid off from my regular job. Decided to start working on it again. That's what happens. So there's supposed to be another power pack on, but these are very expensive, and my last one swelled up really big. So now I'm trying to run on one pack and it doesn't run. But what I'd like to do is just sort of explain what's going on here. At the bottom of the feet are load cells. And when you have 3 load cells, you can take the centroid of this and get the center of mass. And you can then adjust, well, I can't, but the process, there's one for each leg. We'll read that, and they'll create an error, X and an error Y, from the center of mass, and automatically adjust these servos. Always keep the robot foot balanced. That's the general scheme of the algorithm. And the other thing that I just learned in the last couple of weeks is you sort of have to already be in the middle of this center of mass, or you'll do the wrong thing. So if you're actually on two servos, two weights, sorry, if you're on two and you don't know whether you're in front or behind, you don't really know what to do with the robot. So I created this new algorithm called landing, which basically works like an airplane. It tries to land on the two fronts and then bring the rear wheel down. Once you're down, then I let the algorithm that adjusts using the load cells to balance into the center of mass. The idea here, this is really simple algorithm, and I'm hoping it's going to work when I finally get to the mechanical end, is if both legs are balanced and you just shift the hips so that there's no more weight on one foot, you're now on one leg. And if the algorithm always keeps the center of mass on the foot that's standing, you can actually throw this leg forward and the back leg will self-balance. Then you can just sort of drop the knee down until you land again, and now you've planted. Now you're going to shift your weight forward again, and you're going to do this over. And that's the simple algorithm. And that's what I've been working on, and that's the Jody Walker. So my ultimate goal, believe it or not, I tend to pick these lofty, pie-in-the-sky projects because they're really difficult to do, and it challenges me. There's the DARPA Robotic Challenge. I don't know if anybody knows about that. And there's these different tracks, and two of them are virtual, and two of them are real robots. In the two tracks that are real, one of them is Boston Dynamics Atlas-style $1 million a copy robot, and those have been given out to the universities, and they get to compete with those. And then, if you want, and you want to fund yourself and go against Boston Dynamics, you can build your own. That's what I've decided to do. So I am looking for team members who are now registered, and I'm looking for people that may want to play along. And the idea here isn't necessarily to win, but to play along with the guys that make the really big $1 million walking robots. So if anybody wants to play along, I've got a meeting with a mechanical engineer tomorrow, and I'm going to clean this whole robot up and start acting professional about it and get it to where it can actually walk and do things. So that's it. Oh, by the way, I'm Dan Albert.
Like 2 sentences about your load cells, resolution, and...
Okay, yeah, and in fact, I have been back to the company that makes these load cells that I used to work for them. These are 100-pound load cells, so the resolution is not that good with the robot. I chose these over the 10-pounders because I was afraid I'd bottom out the 10-pounder. There's a 50%, if you bang that load cell more than 50% above its max, you're gonna mess up the load cell. However, I've decided, since I'm not putting an upper body on this, that the weight of the robot is low enough that I can go back to the 10-pounders. So I am going to switch to 10-pounders again, which will give me much better resolution. And these are capacitive based. I don't know if anybody knows how load cells work. If there's some that work resistive, they're in a Wheatstone bridge, and this is a capacitive. So basically there's two plates, and they're about 3 to 10 mils apart. And as the load cell compresses and expands, it acts like a capacitor. And of course, it's non-linear, so we need to calibrate it and apply a quadratic to it, linearize it. That's all done.
How are you detecting capacitance?
So there's a circuit there that actually sends a frequency out for the value of the capacitance, and then we take that frequency and then convert it into a weight during the calibration. That's a great question.
capacitor is part of the oscillator, if you know.
Yes.
What sort of frequency comes out typically from that spin?
It's about 150 kHz.
That's good.
I'd be glad to talk to you about that as well. Okay, thanks guys.
Thank you very much. The next person up here is Bill Van Hoy. And he's going to be showing one of the class robots. I've been teaching a class, I call it the HPRC 2013 Club Robot. And this is what it looks like. And this is after phase 2.
Hello everybody. Yeah, I'd like to thank Wayne because it's a great class. I'm learning a lot, and this is after only 2 lessons. We're already moving and chugging around. Actually, the eyes are a little extra I added, but the class is going great. I thought there'd be a lot of people from the class because there's a lot of people in the class today. But there's probably more in the future. So thanks again, Wayne.
Yeah, and our goal is to, at the end of the class, have everybody up and running with a tabletop challenge, phase 1 at a minimum. Some people will be up to phase 2. Okay? We're putting videos for the classes that I've given up online. I'll post those tomorrow or Fridays if you want to see the videos. The cost of the kit clocked in at about $65, but they're all sold out, so you know you can't help you. Any more robots tonight? Camp is going to bring something out. Yay! Are there any more robots after camp? Going one? Oh, we got Alan, okay.
Well, test 1, 2, test 1, 2, is it off?
Test 1, 2, okay. This is my new table bot, Artie, or Artie the Great, he likes to call himself. It's actually an old robot I had called Proppy. It used to use the propeller, but now it's Arduino based, so it's Artie. Basically, it's going to be a table bot that drives around, and and when he scores the goal, it's getting lined up here. He's a little too excited. Well, I'll blame it on batteries, anyways. Robo Games is April the 18th through the 21st. And I think there's only four or 5 days left to register. So if you plan on playing, you need to register. And we will have an HPRC booth, but you must be registered to compete or at least get in the door to hang out at the booth. What was I going to say? Oh yeah, the TableBot Challenge, our tabletop navigation as it's known at Robo Games, is Friday evening, the 18th. Okay, and so some of us, I have been complaining that when you compete in Robo Games, you don't get enough tickets, passes, etc. But with the tabletop navigation, for example, you get 1 pass, but that allows you in for all 3 days. So you know, there's Robo Magellan on Saturday, and the firefighting on Sunday, and BattleBots is going on all weekend long, so it's a lot of fun. So come to Robo Games, and did you talk about the Robot Block Party?
I did.
Okay, very fun. Robot Block Party.
Do it again.
The Robot Block Party in Stanford is on April the 10th, and this is about National Robotics Week. And everybody bring your homebrewed robots, and we'll have a good time. So this is Artie here. Thank you very much.
I think we forgot to mention that the Silicon Valley First Robotics competition is next week, Friday and Saturday. So that's the 5th and the 6th, I believe. Okay. So Stephen and I, along with David Carley and a bunch of other people, are working on a $500 robot. And one of the problems with that is having a motor that can do that. So there are a lot of companies in China that are making small electrical vehicles. And David spent his vacation time visiting some of these companies. I don't know all of them. One of them is called Golden Motors. They make motors for wheelchairs and small electric bicycles and electric scooters. So this is a hubless, brushless hub motor, and with no documentation in Chinese, English, or any other language. And what we've been able to reverse engineer from it, we believe there are 3 leads for power, and then Hall effect sensors coming out. So it has both the encoders and the power in there. And I say this is around 8 pounds, and I'm not sure what the voltage is or how much it can move, but certainly 2 of these could certainly move a 50 to 100 pound robot around the house. And supposedly the single unit price is $75 US. So in volume that would be around $50 for, so $100 for the propulsion system. I mentioned First Robotics.
This Sunday there's a Coca-Cola hackathon at the Hacker Dojo. There's a Coca-Cola hackathon at the Hacker Dojo on Saturday, and we're planning on, we talked about the ideas, we've got a couple ideas for improving Coca-Cola's market using robotics. Coca-Cola's slogan being always within the reach of the consumer, I believe. So we've got an idea for improving the dispenser methodology so that we could get a more compact dispenser on the robot, and then we've got some ideas for robot behavior to try to make it a little bit more attractive. Yeah.
You could have a soda can launcher.
Yeah. That might raise some safety issues.
Some liability issues. Thank you.
Thank you.
Thank you very much. Are there any more robots for show and tell? Going once, twice, okay, shutting down show and tell.